Alright guys, this video is for the practice set 3. I'll quickly go through it and solve some of the problems. Alright, the first 4 questions are from our code. The first 4 questions are code, and they're basically from our Titanic data set or from our graphing data set from lab 3. So let me go ahead and write the code for this. So convert the survived P class and sex comps in the categorical column. We did that in the Titanic video. I'll do it here again. Let me go ahead and zoom in on this data right here. So for number 1, all right, it's basically going to be assume the name of the table is Titanic. So it's going to be literally Titanic bracket comma survived colon equals factor. And survived, survived is a nominal categorical data, so pretty much we're done there. All right, the second one will be passenger class. The passenger class is categorical, but it is a ordinal data set. P class. P class, comma, ordered equals true. And the last one, sex. And again, it's nominal, so we don't have to worry about the levels ordered. Let me go ahead and save this so I can post this for you guys. All right, number 2. Create a bar graph where the x-axis is sex and each individual bar divided by those that survived and those that didn't survive. So again, we did this before. Did you plot Titanic? Aesthetics. X is what? Sex. And the bar is divided by the column, so fill will equal survived. And it's going to be displayed as a bar graph. Right? You don't have to get fancy. That's fine. Create a bar graph where the x-axis is P class and each individual bar is divided by those that survived and didn't survive. Create 2 subgraphs side by side, one for male, the other for female. So what is that hint of? 2 the same graphs side by side. All right, that is your facet wrap. Your facet wrap. Okay, and remember, if we want it side by side, that means column-wise we want it separated. So that means we want it, the facet wrap, whatever that column is, will be to the right of the tilde as opposed to the left of the tilde. All right, so let's go ahead. The bar graph, x-axis is going to be P class. Survived. Bar graph. And we add on another layer. Facet underscore wrap. Tilde. Then the column. Males and females, so sex. All right. Number 4. Change the histogram below into bars of 2. This is easy. I mean, essentially all you need to do is, you can't see it here, it might be too small. But right now it's going to be bars of 5 because the bin width is 5. Right, so we just need to change that to 2. So here I'll literally just say, in the exam I'll probably have you write the whole thing. But here we just need to basically, everything is the same, we just need to change bin width equals 2. All right, number 5. You have training data with 10 rows. You want to build a decision tree. Okay, I don't know how number 5 got into this practice set. This is a mistake. This is classification stuff. This is like the last stuff we learned for the semester. So go ahead and skip that and jump into number 6. All right, number 6. Yep, so I threw this in because there were some mistakes in the first exam. So here, what is Z? So I just wanted to reinforce some of the R things. So here is there Z. Z is what? Z is going to equal the vector 3, 2, 1. And A will equal 0. And we have a for loop for I in Z. Z is just 3, a vector of size 3. Therefore, it's only going to have 3 loops. So loop 1, I is my iterator. I is going to have the value 3. Okay. And now we do line 6. A equals A minus 1. A equals A minus 1. What is A right now? 0. What is I right now? 3. So A changes to become A equals negative 3 after loop 1. Let's go here. Changes to negative 3. Alrighty, so that's A is negative 3. Now we move on to loop 2. All right, for loop 2, I is now going to equal 2. And A is now going to equal line 6, A minus 1. What is A right now? It's negative 3. Here's where you guys might make a mistake. Simple addition. Simple addition subtraction mistake. It's negative 3 minus 2. Okay? So what does A equal now? A is going to equal negative 5. Finally, we're down to the last loop. And now I equals 1. And what does A equal? A equals A minus 1. What is A right now? Negative 5. Again, don't make the mistake. Minus 1. And now A equals negative 6. And we're finally done with the for loop. What does the code below equal? It equals A negative 6. All right? Sorry, that was number 6. Go down to number 7. Given the code below, what is B? All right. Have a little fun here. Given the code below, what is B? And here I think I'll put a little twist or trick in for you for some stuff. The reason why I put this twist or trick in here is because I saw this one's in a job interview question, and it's something you wouldn't know unless it's something you had the foresight to think about. So this is one of those gotcha questions for an interview. All right. So here, let's do it. X equals 1, 2, 3, 4. B is 2, 4, 6, 8. All right, and let's jam. Now we are going to do 4 in I in X. X has 4 values, therefore we're going to have a loop. We're going to have four loops, guys. Loop 1. I is the first value in X, so I equals 1. All right, done. Not too bad. We go to line 6 over here. In line 6, all right, a couple things are happening here. In line 6, we're asking is I divided by 2 greater than 3? So you can do math directly live in the for loop. That's not in the conditional statement, or the for loop. It's not a problem. All right, but look what the problem is. It's I divided by 2. What is I right now? I is 1. 1 divided by 2 is 5. 0.5, sorry. Is 0.5 greater than 3? It is not. We skip line 7, 8, and 9. We go straight down to line 12. And now I'm going to write this whole thing. B is basically going to be I divided by 2. All right, this is the craziness here now. As for the first one, let me go ahead and write this whole thing. All right, okay, now let's do this right. Oh, okay, good. Now let's do this right. Remember, when there's a single equals, we do the right side first. Okay, fine, fair enough. The right side is I divided by 2. I is 1 right now. So the right side is 0.5. Okay, done. Okay, now we do the left side. Enter the craziness. We have these brackets, open bracket, close bracket, to select positions of B. But there's all this crazy math stuff happening. Yeah, that's happening. That's fine. Go inside out. All right, go inside out. Okay, no problem. So I'm going to do B, I divided by 2 is 0.5, fair enough, plus, remember your PEMDAS, guys. Where are you? Plus 2 times I. Now, what do we do first? Do you add the 2 or do you multiply the 2? You multiply. Multiplication happens before addition. So 2 times I happens first. What is 2 times I? It's 1. I'm sorry, 2 times I is 1, so 2 times 1 is 2. All right, you add 0.5 and 2, what do you get? What the heck is that? All right, the numbers within the brackets are positions in the array. So what is 2.5? This will not give you an error in R, guys. This will not give you an error in R. What R will do is, somebody take a guess. I'm imagining one of you guys are taking a guess. All right. The 0.5 gets dropped. That's right. It just looks at the 2 at that point. It just looks at the 2. So the 0.5 gets dropped. It's not about rounding. What happens is R is like, okay, this is rubbish. I'll take the whole number. I'm not even looking at the decimal places because that makes no sense. Even if you put 2.001, that 0.01 gets dropped. If you put 2.9999, then 0.999 gets dropped. The decimal place just gets dropped. So now it's just B of 2 equals 0.5. And when this happens, we come up here, and the 4 now gets changed to 0.5. All right, done. Now we move on to loop 2. I is now what? 2. And then line 6 again, I take a look at it. 2 divided by 2 is 1. Is 1 greater than 3? It's not. We come down here to line 12 again. All right, and this time, line 12 moves a little bit faster. The right side is 2 divided by 2, so the right side is 1. All right, and the left side ends up becoming B 1 plus 2 times 1. 2 times I is 1. I'm sorry, it's 2. 2 times 2 is 4. 4 plus 2 divided by 2 is 1. So 4 plus 1 equals 5. And so what happens here? Boom, comma 1. All right. Now, loop 3. And I believe this is when the madness starts a little bit. Right? We talked about this before, but let's see if you guys remember it. I equals 3. All right, I come here. 3 divided by 2 is 1.5. It's 1.5 greater than 3, guys? Tis not. Therefore, we come down here again to line 12. All right, I'm going to go ahead, copy that here. And the right side is 3 divided by 2. So this becomes now 1.5. All right, good. Now here, again, we're going to have 3 divided by 2, which gives me 1.5. And 3 times 2, which gives me 6. And again, we have this problem, guys, where it's b 7.5 equals 1.5. Now, you correctly already understand that, look, we're dropping that 0.5. All right, we're dropping that 0.5. So it becomes b of 7 equals 1.5. All right, fantastic. 1, 2, 3, 4, 5. Huh? What do we do? Who remembers what we do? Okay, I'm assuming some of you guys are answering the question. Boom. For the 6th value, there is no value, so we put in NA. That's what R does. And then it goes ahead, and for the 7th value, sticks in the 1.5. See that? 1, 2, 3, 4, 5, 6, 7. All right. Finally, we get to loop 4. And I equals 4. I'm going to go ahead and steal this. Stick it over here. All right. Now, again, I come, oh, I'm sorry, I jumped the gun a little bit. Let's go here first. Confirm that 4 divided by 2 is 2. 2 is not greater than 3. Skip that, go down here. Okay, now we can come here. And now, the right side is 4 divided by 2. So this is now 2, guys. And here, this becomes b of 4 divided by 2 is 2 plus 2 times 4, which is 8. So 2 plus 8 gives me 10. All right, and again, we have that problem here that, look, we only have 7 values here. What do we do? You guys know it now. The 8th value will be an A, the 9th value will be an A, and finally the 10th value, oops, will be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Excellent. And now, to answer the question, what is B? That's B, people. All right? All right, so a little twist. That's something you wouldn't have known unless you would have just checked it out. I had no idea when I was asked that. Number 8. I took a guess, though. Number 8, okay. For 8 to 13, these problems, I go ahead and I make this table. I made this table here for you guys. And let's see if I can split the window. Can I split the window? I can't split the window. All right, like magic, I reformatted my window. So we can do, so you have the table up here, and you have the problem down here, we can do it side by side. All right, this is one of the perks of doing it on YouTube. I can always pause and reset up the screen the way I need it. All right, so here we go. Using this table, we want to solve these questions. And again, I just do this just to reinforce to you that you have an understanding of the R code, all right? So z equals 1, 4. TT now, here we go. TT now is going to be head MDF price, comma, 5. All right, does anybody remember what the head function does? That's correct. The head function gives you the first couple of rows, the first values of whatever you're deciding after that comma. So let's go inside out. All right, MDF. This table's name is MDF. MDF dollar price. That basically means give me the price column from this table, which is this right here, this whole column. All right, this whole column is this part right here. All right, this part right here is this whole column. This whole column is being passed in the head function, comma 5, which means we're only selecting the first 5 values of these set of numbers here. The first 5 values of these set of numbers is 4, 1, 3, 5, 2. So TT equals 4, 1, 3, 5, 2. All right, 4, 1, 3, 5, 2. Now, R, sequence function there, R equals alrighty. So now we do for I in Z, this for loop. Okay, now notice what's going on here, people. We got a double for loop. So we have a for I in Z going on, and then we have a for X in whatever this is going on. All right, so let's start off with for I in Z. For I in Z, Z is 4 values. This for loop will go, the outer for loop will run 4 times. Loop 1, I is the value 1. And now we get started. As soon as we get into line 7, we triggered another for loop. Now, this inner for loop from line 7 to line 10 has no idea that it's in another for loop. All right, from line 5 to 11. No idea. So that means that when this for loop starts, it will finish. It's going to finish. And when it finishes and we come down here, then this outer for loop will continue. Do you see what I mean? So what ends up happening is I will equal 1. All right, I will equal 1. And then the inner loop, and I'm going to denote the inner loop by the word I loop. All right, the I loop starts. I loop 1. Sorry, 1. All right, now this I loop 1 gives me a little bit of problems because I don't give you a straightforward vector. What am I doing? I'm basically saying go to R, the vector R, choose the first value, the third value, and the 5th value. Therefore, X is going to iterate over the first, third, and 5th values in R. What are the first, third, and 5th values in R? It's 2, 6, and 10. So, just so there's no confusion, I will just write here X over 2, 6, and 10. All right, X over 2, 6, and 10. All right, so that's what X is going to overrate. So it's going to be, the inner loop is going to run 3 times for each outer loop iteration. Here we go. I loop, X value, X is going to be 2 first. All right, X is 2. And then we finally come down here to this thing. Equals I plus X. All right, cool. Let's do the right side first. Always do the right side first. Oops. Don't know why it keeps doing this to me. There we go. Equals I plus X. All right. What is I plus X? Right now, what is I? It's 1. What is X? It's 2. 1 plus 2 is 3. So TT, n row of R, equals 3. All right. Now, what is the n row of R? And remember, the capital N row function basically just gives you the number of either rows in a table, or it gives you the number of elements of a vector, the size of a vector. In this case, R is a vector. So n row of R is 5. So this becomes TT of 5 equals 3. All right? I'm sorry, yeah, TT of 5 equals 3. So now what ends up happening here is I go here to TT, I change the last value to 3. Done. All right? I'm not done though for my inner loop. Remember, my inner loop still keeps going. It has no idea it's contained within a loop. All right? So inner loop 2, x now equals, we have that over here to make things easy for us, x now equals 6. All right, and now we can move slightly faster. N row of R is going to be, again, 5. And notice, by the way, this is a little trick to help you speed up this problem. I'm going to do it the long way, but some of you guys might even realize there's a shortcut here. That TT N row of R never changed. It's always going to be TT of 5, TT of 5. That means no matter what happens, we keep changing the last value of TT, which means we could always fast forward to the end and just solve the problem, but I'm going to do the long way because why not? It's a YouTube video. You guys can just forward this if you want or move it fast. So TT of 5 equals I plus X. What is I right now? It's 1. What is X? It's 6. Boom. Sorry. So TT of 5 now, this is 7. All right. Now I do I loop of 3. All right. And now what is X? X equals 10. And now again, I have TT N row of R plus I plus X. This becomes TT of 5 equals, what's I? Again, I is 1. What is X? It's 10, 11. So TT of 5 now becomes 11. We are finally done with the inner loop. We come back down here. The outer for loop says, okay, I, are you done with Z? I says, not even close, man. I'm only in 1. I got to keep going. So boom. We now move on to the outer loop. We now move on to loop 2 of the outer loop. And when we move out to loop 2, I now becomes the value 2. And now the I loops start over again. The cool thing here, this is X. And the X's are, we know what they are, they're 2, 6, and 10. So I will go ahead, make this 5. But now the math changes, all right? So what is I plus X? I is 2, X is 2. This becomes 4. Becomes 4. Over here, in the second loop, X is 6. I plus X is what? 2 plus 6 is 8. This changes now to 8. I come down here, X is 10. TT of 5 now is X plus I. X is 10. I is 2. This becomes 12. Now this becomes, 12. All right. And that's after loop 2. The inner loop finishes. We come back here. The for loop asks I, are you done? I was like, nah, halfway point. Got to go move on to loop 3. Move on to loop 3. All right, move on to loop 3. I is now 3. Start the party. Oh, sorry. All right, and start the party again. TT of 5 is I plus X. It's going to be 2 plus X, so TT of 5 is not going to be 5. So now this becomes, I'll stop updating over there. You pretty much get I'll update it once we get to the final one. For loop 2, TT of 5 becomes I plus X. That's 6 plus 3, so this becomes 9. So the last value now becomes 9. And now we come here. I plus X is 10 plus 3. The last value now becomes 13. All right? We finished the inner loop. We come here. I is like, all right. Finally on the last loop, guys. Finally on the last loop. Take this, copy it, I is now the value 4. Loop 1, tt of 5 is what? X plus I, or I plus X. This is 6. Last value becomes 6. But when we come back here, I plus X becomes 10. Last value becomes 10. And then finally, when we come here, the last value becomes I plus X, 4 plus X. I'm sorry, 4 plus 10. It becomes 14. And finally, we come down here, and I is like, I'm done, I'm done. And it's at this point, now we come back here to TT, the last value of TT literally becomes 14. So when I say, hey, what is TT after this whole loop thing runs? 4, 1, 3, 5, 14. Fun, huh? All right. Again, I apologize to do that to you guys, but you know, it's good practice on your theoreticals. Number 9. All right, we just did one for loop, going back to another. This is, I'm gonna zoom in a little bit because it's not there. All right, perfect. What is B? What is B? Let us do B. All right, now V. What is V? Start off with V. V, again, we're taking the head of the price column in the MDF table. So MDF price is this column right here, comma 9. Now it's saying V is the first 9 values. All right, no problem. So V is 413, 524, 684. Alrighty, 413, 524, 684. Perfect. Now we go to Z. Look at how sneaky I get. Now Z, all right, don't mess this part up, guys, is tail V comma 5. What is V right now? V is these values. Comma 5. Now, you guys know what head does. Head gives me the first values. So what does tail do? That's right, it gives me the last values. So tail V comma 5 is the last 5 values of V. And the order is preserved. So the last 5 values are what? 2, 4, 6, 8, 4. So Z becomes 4, 6, 8, 4. You see that? See that? The last 5 values, but the order is preserved. 2, 4, 6, 8, 4. All right, what is B? Line 4. B is just a empty. See how it's C, parentheses, nothing in it, guys? What is it? It's just an empty vector. If you were to see that in R, you would see that nothing is there. All right, nothing is there. But it exists, but it's there. All right, now we have a for loop for I and Z. Z is 5 values. We have a loop with 5 values. Let me go ahead, shrink this up a little bit so you can squeeze all the 5 columns in here. All right. All right, so loop 1. Let's put it down here. Let's scroll down a little bit. Loop 1. I is the value 2. All right, now we go to line 7 of the question. If I minus 1, oh, we have, okay, look at that. We got a double ampersand. This is both conditions must be true, okay? Both conditions, when you have a double ampersand, it's like having a single ampersand in our logical slicing within the vectors or data containers. In a for loop, in an if-else statement, it's 2. So when you have 2 conditions like that, or however many conditions, both must be true. So let's look at the first one. 2, I is 2 right now. 2 minus 1 is 1. Is 1 greater than or equal to 3? It's not. It's false. Because this first condition is false, I don't even have to look. I can highlight. I don't even have to look at the second condition. Because this is false, it does not matter even if that's true, because both have to be true for me to go down here. I go straight to else, and I do B equals C, B, I. All right, what's going on there? What is B? All right, so here might be some sort of confusion. Remember, do the right side first. So remember, C of a vector and a number, or number and vectors, or whatever combination of that is, just gives you a giant vector. So here, if I have a empty vector combined with the value 2, what's that going to give me? Well, it's just going to give me another vector. In this case, just the value 2. So B now actually has the value 2 in it. Right? Remember, B equals 2 is the same as saying the first position of vector B is 2. Because remember, the most base data container in R is a vector. All right, cool. We're on the board. Loop 2. All right, loop 2. What is I? I is now, we're iterating through Z. I is now equal 4. All right, we come down here to 7 again, line 7. Is 4 minus 1 is greater than or equal to 3? Yes, it is. This is true. Go here. 4 minus 4 is 0, which is less than or equal to 3. That is true. Both conditions are true. We go down here. And now in 9, it's going to be B n row of B plus 1 bracket equals I, which is 4. So what's going on inside here? N row of B is what? N row of B is 1. There's only one element in it. 1 plus 1 is 2. So B of 2 equals 4. Easy. All right. Loop 3. I now has the value 6. All right. Come down here. 6 minus 1 is 5. Is 5 greater than or equal to 3? It is. And 6 minus 4 is 2. Is 2 less than or equal to 3? It is. So we go do execute line 9 again. I'm just going to go and copy this. All right, but this time line 9 is going to equal I, and I now is 6. All right, and we go ahead and do the math. N row of B is now what? It's 2. 2 plus 1 is 3. So B of 3 now equals 6. All right, I go ahead to my loop 4. Oh, let me go ahead and add that there. All right, go my 4th loop. What is I now? I equals 8. All right, I equals 8. And now, copy this again. Nope, not copy it. First, let's go through our conditions. 8 minus 1 is 7. 7 is greater than or equal to 3. Excellent. And 8 minus 1 is 8 minus 4 is 4. Is 4 less than or equal to 3? It is not. This is false. We skip this part, go straight to the else. And now again, we have B equals C BI. All right, so I'll copy this part. All right, but instead of an empty vector and 8, so this is I, so this is going to be 8. And this vector right here will be B. And what's B right now? 2, 4, 6. So what does B equal now? B is now one vector, 2, 4, 6, 8. Right? It just overwrites the whole thing to become this. And now finally, I go to loop 5. What is I now? I is 4. B equals, actually before we even get to that, 4 minus 1 is 3. 3 is greater than or equal to 3. Excellent. I come over here. 3 minus 4, I'm sorry, 4 minus 4 is 0. 0 is less than or equal to 3. Both conditions are true. We come down to this part again. I'll just copy and paste this part. Oh, right, a little space. I'll scoot over a little bit. All right, this is going to equal 4. B n row of B plus 1. What is n row of B now, guys? 4. So 4 plus 1 gives me B of 5 equals 4. And finally, the last value of B is 4. And so here the question is, what is B? B basically ends up being Z, 2, 4, 6, 8, 4. All right? And that is number 9. Number 10. Given the code, oh, we got a lot of stuff going on here. So let me move this here a little bit just so you guys have some more. All right. So given the code below, what is V? All right, what is V? So V starts off with this value right here. Nice. Let me put that in there. V equals all right. Z now is a little bit crazy. Z equals sequence of something, right? So let's write down the sequence real quick. Z equals the sequence 2, 12, and then madness ensues right here. I put this in here right here. Notice I have a comma and then this part right here. It's safe to say that this part is going to give me that last number I need for the sequence. Okay, let's go ahead and do this. MDF table, excellent. All right. Now, here, you've never seen me use syntax like this before. I should probably change this up a little bit. All right, let me, I mean, this kind of syntax is valid within the world of data tables because data tables can always use syntax for data frames. I just wish I used data frame syntax instead. Yeah, it looks like I did it for both of them. All right, that's fine. All right, that's fine. Right, it doesn't really matter. You can still decipher it. So here, comma, here's a single comma. This is the row filters. This is the column. All right. So let's start with the row filters. The row filters right here are saying what? MDF dollar ticker, the ticker column has to equal apple. Again, this is data frame syntax, not data table syntax. But you guys can pretty much follow along anyway. But this is valid for a data table as well, because data table can do both data table syntax and data frame syntax. All right. So here I'm basically saying ticker equals apple. I'm filtering for these 4 rows. And date equals 2017-03, just this row. So the first filter right here, okay, the first filter right there is going to be these 4 rows. And then this filter right here, 2017-03, would just be this one row over here. Because out of these 4 rows, the only date that has 2017-03 is this one. All right, excellent. So I'm choosing this row right there. Nice. Now, comma, out of that row, I'm just choosing the price column. So out of this whole row, I'm just choosing that price column, which is a value 2. So the last value here becomes 2. Everybody see that? So Z equals the sequence 2, 12, 2, 12, 2. So this, let me just move this over right here. Z then ends up equaling 2, 4, 6, 8, 10, and 12. All right, 2, 4, 6, 8, 10, and 12. All right, 2, 4, 6, 8, 10, and 12. Excellent. So that is Z. Now for here, for V, look what I got going on. I just got a little bit of slicing and dicing, so this is not a problem. Okay, so remember, when we have something like this, we do the right side first. So what's the right side saying? The right side is saying, I'm choosing the 1, 4th, and 5th position of Z. All right, so what is the 1, 4th, and 5th position of Z? It is 2, 1, 2, 3, 4, 8, and the 5th position is 10. Easy. Now these values are going to go into the vector V. I'm going to write the whole vector V. Do this. All right. Okay. So, where is it going? All right. It's going in the 2, 3, comma 6 position. All right, so let's go do it. 1, 2. This becomes 2. Excellent. Now 3 becomes 8. Oh, actually, hold on. Let's do that down here. All right, so right here, let's do it. So the second position becomes 2. The third position becomes 8. And the sixth position becomes 10. 1, 2, 3, 4, 5, 6. Becomes 10. So what is V? V ends up being 2, 2, 8, 5, 2, 10, 12. All right, let's go to number 11. Number 11. Excellent. Given the code below, what is 2 more bombs? Right, no problem. Given the code below, what is, let me go adjust this now. All right, excellent. Given the code below, what is V? All right, stock is head MDF4. Oh boy. Stock is head MDF4. Now, I'm not choosing a column here. I'm choosing the whole table. So if I'm choosing the whole table, head MDF4 now gives me what? It's not going to give me it's now, instead of giving me the first values of a column, it's giving me the first values, in this case, the first 4 values of the whole table, okay? Of the whole table. So stock, the variable stock, is now going to equal ticker, date, total assets, total debt, and price. Okay? Scooch this over a little bit. All right, now I'm going to take the first 4 rows, which is all going to be FB. Date is going to be 2017-03. I'm just going to cheat a little bit, use a little. All right. Now I'll do total assets, 150, 100, 500, and 100. Find total debt, 3025, 100, 20. Excellent. And price, which is 4135. All right. Okay, excellent. So that is the stock. So stock now becomes a table, this table right here. We come here, stock C. What is stock C? Stock C is stock table, all the rows, 2. Now notice I put a 2 here. I don't put a column name. So if I put the 2 in there, what does that mean? That means the second column. All right, if I don't put the column name and I just put numbers in there, it's basically the position of the column. So stock C basically becomes all the rows, and you guys remember what the as vector does. As vector, actually, I'm sorry, I never actually told you what as vector does. As vector basically is just another way to take rows of a table. In this case, it's redundant because what ends up happening here is the second column becomes a vector anyway. But in some tables, like for instance, there's a type of table in R called XTS tables. When you take a column of an XTS table, unlike in data table where you take one column, when you take one column of an XTS table, it remains an XTS table. So you have to explicitly call the as.vector to make it a vector, right? In this case, it's kind of redundant, but that's all as.vector does. So in this case, it's not really doing anything. It's just, again, it's making a vector already a vector. So here we do stock C is going to be all the rows of the second column of stock. Well, what's the second column? It literally is the dates, and these dates are numbers. So this becomes all right, these ridiculous numbers. And now what is return? Return is just an empty vector. Again. Sorry about that. All right, so now we do the for loop. We set this up. Now let's do the for loop. All right. Now for I in 1 to n row, stock C minus 1. Here I give you guys a little problem again. All right, and to the right of in, you have to figure out what that vector is going to be. I'm making it dynamically. So we see a 1 colon there. All right, that's a hint. 1 colon. But now to the right of it, we have this parenthesis, n row stock C minus 1. Okay, n row stock C minus 1. So we start off with what is n row stock C. What is n row stock C? There's 4 elements there. The answer is 4. What is 4 minus 1? 4 minus 1 is 3. So this becomes 1 colon 3. Oops, let's do I. This becomes I in, my God. All right, 4I. This becomes 4I in. For I in 1 colon 3. All right, that's basically what this becomes, guys. I'll make that lowercase, annoying me. All right, sweet. All right, so let's go ahead and do this. 3 loops, loop 1. And again, I apologize for those large, I mean, even though they're dates, they're numbers, I apologize for that because it's going to make the math really ridiculous. There's no reason for me to give you such ridiculous math. But anyway, let's go with it. For loop in 1, I equals 1. All right, I equals 1. And this becomes return of I, return of 1, equals stock C, I plus 1. What is 1? I plus 1, that's 2. So what's the second value of stock C? Well, that is 2017-06 divided by stock C of I, stock C of 1, which is 2017-03. All right. Minus 1. All right. I'm not going to go ahead and even solve for that because that's just ridiculous. I'm not going to give you a problem like that. But let's go ahead. So whatever that value is going to be in the first value. Return loop 2, I equals 2. Right, and now it's going to be return 2 equals the value stock I plus 1, which is 3. So stock C of 3, which is what? 2017-09. Divided by 2, a stock C of 2, which is 2017-06. And that's what return of 2 is will be, whatever that answer is. And loop 3, I is now 3. And I is 3, so return 3 now equals stock C of I plus 3 plus 1, which is 4. That's 2017-12. Divided by stock C of 3, which is 2017-09. Minus 1. And whatever that is, that'll be the third value returned. And then finally, we come down here to number 9, and we say V is the first value returned. What is V? So basically, whatever this right here, this division is, that's going to be the answer, right? Again, I apologize for the large numbers. There's no reason for that. There's just no reason for that. Oh, God. There you go. All right, so that's number 11. Finally down to number 12. Number 12 is probably a little more saner. All right, guys, let's do number 12. There we go. All right. Given the code below, what is V? All right, again, we have stock equals tail, MDF n row, MDF divided by 4. So here, a couple things. First off, again, within the tail, I select all of MDF, no column. That means I'm selecting literally all the columns, right, of this table, some bottom rows of the MDF table. Now, how many of those bottom rows? This thing is going to tell us, all right? So we're doing a little math in here. N row MDF is what? N row MDF is basically, remember, all caps N row on a vector gives you the size of the vector. On a table gives you the number of rows. So here we have, this table has what? 4, 4, 4, has 12 rows. So this part, the numerator of this, is going to be 12. 12 divided by 4 gives me 3. So this basically becomes 3. Tail MDF 3. Tail MDF 3 basically means the last 3 rows of this data container, which is a table. So it's basically going to be these guys. I wonder if I could copy and paste this. Hold on. Let me see. Copy. Nah, no, that didn't work. So I got to write that again. So here's basically going to be, let me cheat a little bit. Grab this. Makes it a little bit easier. All right, and this variable will be called stock. Make it bold. All right, so this will be stock. This is now going to be Tesla. Got my dates. It's going to be 200, 350, and 150. Until that will be 40, 70, 50, 40, 70, and 50. And the price will be 1065. 1065. Excellent. All right, now we do stock 2. All right, now what is stock 2? Stock 2 is going to equal the head of stock. Oh, look at that. The head of stock. I'm taking the head of this data container. Again, I'm doing n row stock minus 1. I'm playing these games. Okay, so n row of stock. What's the n row of stock? 1, 2, 3. 3 minus 1 is 2. Excellent. So head of stock, comma 2. The first 2 rows of this is going to be stock 2. Sweet. Literally just copy this, paste it, and this is now stock 2. Fantastic. All right. Now, stock C is going to be simply as dot vector. Now again, as dot vector is redundant here because this syntax right here gives us, in data tables, gives us a vector anyway, but it's not going to do anything, so we could throw it in there as well. So stock C is going to be literally the 4th column of stock 2. What is the 4th column of stock 2, guys? 1, 2, 3, 4. It's total debt. So the values, all these values will now be in stock C. So stock C will just be a vector with the values 40 and 70. All right, and now we do this for loop for I in stock C. I in stock C, it's going to only have 2 loops. Loop 1, return is going to equal, okay, so I jumped the gun here a little bit. Return equals 0. Forgot that variable. Move this down a little bit. That's from line 4 right there. From line 4 right there. So loop 1, I in stock C, so I is going to equal the value 40. And now I'm going to do return equals return plus I. So this is going to be return equals 0, because return is 0 right now, plus 40. So return is going to equal 40. I come over here, overwrite this. Now I go to loop 2. And now I is going to have the value 70. And now it's going to be return equals return. What is return right now, guys? Up in line 114, it's 40. Plus I, which is 70. Oops, 70. So what does return end up being? 110. And now, right here, the final line, V equals return. So V is basically 110. What is V? V is 110. All right, and now we're finally on our last question, number 13. Okay. All right, for number 13, I have the old syntax again here for line 2. Hold on. Again, I apologize for the syntax over here, because the syntax over here is also the older syntax, but it still works. It still works. But just review from practice it to the new syntax using data tables. Okay? But anyway, let's go ahead and do the problem. Stock equals as vector MDF price. All right, fine. Here we're now taking the as dot vector of MDF price, the price column. All right. So it's going to be all of the price column right here. And again, as dot vector is being redundant because this is going to give me a vector anyway. So let's go ahead and do that. Stock now, it's going to be a vector. All right, so that's the whole vector. Now what is max v? Okay, here we go. Max v is going to be insane. Let me move this over a little bit here so we can see it clearly. So max v is going to be max of, we have a couple functions here. We have the max function now, all right? We have the head function, and then we have within the head function this madness. So go inside out again, all right? So we'll do the head function first. Head function stock, excellent, it's this vector, sweet, all right? So I'm taking the first values of this vector, but how many of them? All right, I have to play the same game that I did in the previous question. MDF, I'm slicing MDF over here. Here's my comma. So this is basically filtering my rows. So let me filter my rows right here. Where MDF ticker is Tesla. Excellent. It's going to be these 4 rows right here. Okay? And the second condition. Out of these 4 rows, where MDF date is 2017-03. Okay, so out of these 4 rows, only this date is 2017-03. So it's this row right here. And now we do comma. Out of this row, it's the price column. So out of this row, we just want the price column. So out of this row, the price column is 4. So this whole thing is basically going to give us 4. So we want the head of stock 4. All right, Excellent. So that's going to be this. Let me just write what we have so far. Max underscore V equals max head stock 4, which is going to be the values 4, 1, 3, 5. All right. Now from here, right, now we can do the outer function part. We want the max of this vector. Well, what's the max of this vector? That's easy. Max underscore V ends up equaling 5. Done. All right, so we're done with line 2. Now we can go ahead and do line 3. And now there's a new function here. So we have the tail stock, and now I have two things going on here that you guys have never seen. In the tail part, I now have a negative number. What does that mean? We'll get to that in a second. And outer here, I don't have the max function. I have a which.max function. What does that mean? Which.max is basically the position of the maximum value. So where the max gives us the maximum value, which.max gives us the position of the maximum value. So for example, let's say this was which.max. Let's say for in line 122 in the Excel sheet, instead of max, that was which.max. So max gives us the largest value. Fine. Which.max gives us the position of the largest value. So then the answer would have not have been 5. It would have been 1. It would have been 1, 2, 3, 4. The fourth position has the maximum value. So then max underscore V would have been 4 instead of 5. So that's what which.max does. It gives you the position of the maximum value. Right? Pretty cool. Pretty nifty function. Now, again, we have a function within a function, so we do the inside part here first. Now, let's address this negative. So I want tail of stock. All right, this is stock right here. And I want the tail of it. I want the last few values. But which last few values? I don't have a positive 3 here. I have a negative 3 here. What does the negative mean? Okay, so basically what this means is give me all of the last values, all right? Give me all of the last values except for the first 3. That's what it's saying. If you want it basically, this is so in situations where you don't know how many you want of a data container, the beginning or the top, the first couple of values or the last couple of values, all you know, you want all the values except for excluding the first 3, right? And this is what it's saying. So this becomes m underscore lock equals which.max, parenthesis, and it's basically going to be all the values of stock except for the first 3. All the values of stock except for the first 3. So this becomes now 5, 2, 4, 6, 8, 4, 10, 6, 5. Ta-da! See that? And for those of you thinking right now in your head, this is where somebody would ask this question. So what would head stock negative 3 be then? Head stock negative 3 then would be all the first rows of stock, the first values of stock, except for the last 3, right? So it works the same way. The negative is excluding the opposite side. So if it's head stock negative 3, it would be all the first values except for the last 3. And in this case, tail stock negative 3 is all the last values except for the first 3. That's how it works. All right, pretty cool. Pretty cool. All right, now let's do the second part of mlock of line 3 over here. So m underscore lock now is going to be equals which.max. Aha, let's have some fun here. First step, find the max. Right there, 10. Okay, now I'm not giving the value 10. This is a which.max function. I'm giving the position of 10. So now here I'm counting 1, 2, 3, 4, 5, 6, 7. The 7th position has the highest value. Therefore, 1, 2, 3, 4, 5, 6, 7. M underscore lock will equal 7. Right? That's the way it works. Now be careful. Some of you might be tempted into saying, oh, okay, the 10th one, which over here is the 10th position. No, 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 no. Which.max does not see this array over here. Which.max only sees this array. That's all it cares about. So here in this world of which.max, 10 is the 7th, is in the 7th position. All right, so just be cognizant of that. Now we go to number 4. And number 4, we got a min going on, and then we have a stock, and we have some slicing going on using the mlock variable. No problem, no problem. So what is m underscore lock? M underscore lock is 7. So this just becomes stock 1:7. No biggie. Stock 1:7. It's just the first 7 positions of stock. So min v is going to equal minimum of the stock values from 1 to :7. So it's going to be literally 4, 1, 3, 5, 2, 4, 6. All right. The 1, 2, 3, 4, 5, 6, 7. There you go. 1, 2, 3, 4, 5, 6, 7. Excellent. And from here, now I just take the minimum of that value, which is going to be what? Min underscore v equals, what's the minimum value, guys? It's 1. All right. And now I'm finally ready for v. V is going to equal max underscore v, which is what? It's 5. Divided by min underscore v, which is what? It's 1. Which gives me a v of 5. See? Easy. Excellent. So this concludes now our video for practice set 3. And so your Titanic video that I made for you and now your practice set video I made for you, please have these videos viewed. Please make sure you view these videos before our session on Sunday at 2 o'clock. And the session Sunday at 2 o'clock, we want to basically, it's more of just an open Q&A for you guys to talk about the material here. So any questions about the practice set or what I did with the Titanic data or the graphing or any errors in your code when you guys were doing the graphing, that's when we're going to go over it. Okay? So I'll see all of you guys on Sunday at 2 p.m. All right, stay safe, everybody.